Hello friends, welcome to this lecture. In this lecture, we would be understanding the background about AutoKeras. AutoKeras is an AutoML system based on Keras. It is developed by a data lab at Texas University. The goal of the AutoKeras is to make machine learning accessible to everyone. Now, here is a pseudocode where I'm importing the AutoKeras as SK, and then I'm invoking the image classifier on the AutoKeras package, and then I'm doing the fit for the training features, X-train and Y-train. Finally, I can make the predictions. So the idea is be able to automate the ML libraries in a way it's more accessible for a user who's not even accustomed to using deep learning models. Now we're going to understand about neural architecture search. Neural architecture search, as also called as NAS, is basically an algorithm that, given your specific data set, searches for the most optimal neural network to perform a certain task on that data set. AutoML is then a suite of machine learning tools that will allow one to easily train high performance deep networks without requiring the user to have any knowledge of deep learning. Now, what are the takeaways using that neural architecture search? First, neural architecture is a process of automating architecture searching in deep learning. So if you can automate it, then obviously you don't have to write manually different machine learning or deep learning models and then optimize it. NAS can perform that optimization for you. Now, NAS methods outperform manually designed architecture on tasks such as object detection and image classification. Let's talk about the type of search strategies. First of all, we have three different search strategies. The first being reinforcement learning is commonly used in neural architecture. Consider generation of neural architecture to be agent's action and agent's reward is a performance of the validation. Neuroevolutionary algorithms use gradient-based methods for optimizing weights and use for optimizing the neural architecture. Thirdly, Bayesian optimization is hyperparameter optimization used in NAS. Some work derives kernel functions for architecture search space in order to use classic GP-based Bayesian optimization. Now we're going to talk a bit about Bayesian optimization. Bayesian optimization is a sequential design strategy for global optimization of black box functions that doesn't assume any function forms. It is usually employed to optimize expensive to evaluate functions. In other words, Bayesian optimization builds a probability model of the objective function and uses it to select hyperparameter to evaluate into true objective function. Now, in this graph, you can see the true objective function is a fixed function, right? So it may have set of hyperparameters and you can see it's a function, right? And now what we're going to do, this function actually is also on the RMSE score. So now in the next graph, if you observe, let's use a random forest model to get the RMSE score for all possible hyperparameter combinations. So assume there are 10 points and we got the score for 10 points using random forest model. Now in the next graph, build a surrogate model which is nothing but probability representation of objective function. This is essentially a model trained on hyperparameters. Considering we have 10 points, how should we decide which parameter for the 11th sample? So now our quest is, even if we have a surrogate model, how do we decide which parameter for the 11th sample, right? So we need to build an acquisition function, also called selection function. The next hyperparameter of choice is where the acquisition function is maximized. In the figure, the green shade, if you see in the lower chart over here, is the acquisition function, and the red straight line is where it is maximized. Therefore, corresponding hyperparameter and its objective function score, represented as a red circle, right, is used as the 11th sample to update the surrogate model. Then, after using the acquisition function to determine the next hyperparameter, the true objective function score of this new hyperparameter is obtained. Since the surrogate model has trained on the hyperparameter true objective function score pairs, adding a new data point update the surrogate model. So as far as you can, using the surrogate model, train on the hyperparameter and get the true score of the objective function, then adding a new data point update the surrogate model, right? You can keep updating the surrogate model likewise. Now let's talk about uh, some of the genesis of AutoKeras. Automated machine learning and neural architecture search, as such NAS, the algorithm that makes AutoML possible when applied to neural networks and deep learning. Google's AutoML is a proprietary algorithm. It is a bit expensive. An alternative to AutoML is the open source AutoKeras built around Keras and PyTorch. Of course, Google AutoML is proprietary algorithm. It's a bit on the expensive side. Um, yeah, and I think we are repeating this text, so that's fine. We can skip it. Google AutoML enables developers and engineers with very limited machine learning experience to automatically train neural networks on their own data sets. Under the hood of Google AutoML algorithm uh, are iterative. So what are the uh, main objectives of Google AutoML? First, training a network on a training set. Second, evaluating the network on a testing set. Third, modifying the neural network architecture, right? Fourth is tuning the hyperparameter, finally repeating the whole process. I think you're quite obvious, how Google AutoML operates. And here is a picture for automated machine learning. You can see that if we are doing an object detection, AutoKeras, uh, you can see there are handbag, shoe, and hat. If we run the model these labels through our cloud AutoML, then we can definitely evaluate whether a particular object was a sandal versus shoes versus cap and the bag and purses, right? So these software projects can help you to train models automatically with little intervention. They are great options for novice deep learning practitioners to obtain a baseline to beat later on. So both Google AutoML and AutoKeras are powered by algorithm called neural architecture search. We did discuss about it in the prior uh, introduction. Given your input dataset, a neural architecture search algorithm will automatically search for the most optimal architecture and corresponding parameters. NAS essentially replaced the deep learning engineers practitioner with a set of algorithm that automatically tunes a model. In the context of computer vision and image recognition, a neural architecture search algorithm will accept an input training dataset, optimize and find the architecture building blocks called cells. These cells are automatically learned and may look similar to Inception, Residuo, or Squeeze Fire microarchitecture. Continually train and search the NAS search space for more optimized cells. Now, here are the steps involved in AutoKeras model execution. Number one, the user calls the API. The searcher generates a neural architecture on CPU, right? The first block basically generates the neural architecture on the CPU. Third is neural networks with parameters on RAM from the neural architecture. So using the graphs, you can definitely come up with the real neural network with the params, right? Corresponding to the architecture. Then the neural network is copied to the GPU for training. So you can see the third quadrant, that's where your model is getting copied for GPU training. If it's a CPU, probably you're doing it CPU, but normally you're not going to run big AutoKeras models on a CPU. Trained neural networks are saved on storage devices. That's the fourth quadrant, and the searcher is updated based on the training results. So what are the benefits of AutoKeras? Ease to use and locally deployable system. We need to adapt neural architecture sizes to the GPU memory during the search. Configurable API, high level of programming experience is not needed of AutoKeras. All right, friends. So I'm going to wrap up the lecture over here. I hope you have a basic understanding of the AutoKeras model. And in the next lecture, we will be building our AutoKeras model for gaining some depth and knowledge of building the AutoKeras model pipeline. Thanks for joining, and I'm going to see you in the next lecture.